Okay, yeah, thank you. Thank you very much for the introduction. Hi, my name is Marchi. I also go under Control Chaos. This is the second time I've been able to present with the Tokyo Developer Study Weekend crew, so
Welcome
I
back.
am excited to be here. Yay! Okay, so the topic for today is going to be procedurals and path tracing. We're going to be doing some procedural modeling inside of Notch, and we're going to be using the RT glass material to make it look nice and shiny. Okay, so just kicking off, so who am I? It was pretty well explained, but yeah, I'm a VJ and an animator and 3D modeler by trade. I stumbled into Notch because I was looking for a real-time way to make a lot of content really fast, and it's been extremely useful in my workflows going forward. So I've been using it for a lot of IMAG looks in nightclubs. I've been using it for a lot of DJ visuals, and general just playing around with some artwork. But one of the favorite things I've done was I had a chance to partake in the Notchmeister Cube Challenge, and that really got me started on trying to build using only the tools that Notch has as a challenge. And a lot of the talk today will sort of come out of things I've learned from that. So what is a procedural in Notch? I didn't have a good way to explain it, so I just stole the paragraph from the Notch manual. So in Notch, a procedural is a three-dimensional field of signed distances, and this is also known as a signed distance field. So an SDF alone cannot represent geometry, but surfaces and volumes can be extracted from the field and rendered conventionally. So this is basically, we can take the generators in the procedural system and match them up with the procedural meshing to turn these signed distance fields into geometry. So here are three examples from August 2020 when I started playing around a lot more with procedurals. So on the left-hand side, we have a really liquid sort of oil in water effect. In the center is a snow globe made using unioning different shapes together. And even the house was made in procedurals. And on the right-hand side is a technique we'll be covering later called the onion displacement. So that's giving us those really nice organic curves. Everything here was made completely inside of Notch. There were no external models or assets brought in, except for a font file, the text. Again, here are three more examples of the glass. This is from this year in January. I wanted to try something a bit more detailed, so I've put the glowing cylinders and the glowing spheres in the middle to try and add some more detail on the reflection and the refraction. And the shape on the right-hand side over here is actually one that we'll be creating in our first of the two workshops later today. Here are the final three examples I'll be showing. So on the left-hand side is the Notchmeister Cube Challenge. So the bottle and the water were all made with procedurals. The cup in the middle is showing a simple subtraction Boolean that's running in real time. And on the right-hand side, the cooler contains a bunch of glass bottles, which will be showing up in our second session later today for when we look at how to create colored liquids and how they'll interact with light. So let's get started with this one. So this workshop is going to be focusing on the path traced and ray tracing lighting rendering. So due to that, it is going to be quite intense on your graphics card and your CPU occasionally. So I use a 2080 Ti NVIDIA graphics card. So I've built these scenes mainly around that level. If you do come into any sort of major stuttering or if it's slowing down a lot, you can drop the resolution down in the Notch files just to work along. Both the procedurals and path tracing topics are huge, and you could probably do a 3-hour talk on each one alone. So I'm just focusing on very specific tools that we'll be using in our workshop coming up afterwards. All right. And here is the schedule for how we'll be going through today. So our first session of 50 minutes, we'll be going through the introduction to procedurals and path trace glass and just working through what they can do and some of our little best practices. The second session we will be building the glass tower purple look, learning about how to use the cloners and how to set up something that is designed primarily for a square border, like an Instagram page. And then the final session will be taking those glass bottles that we saw in the other one, creating those, making them animate, and then having light actually change the color of all our shadows as they pass through those bottles. Followed up by a Q&A session and anything that we might have skipped over really quickly in the first lot. If anyone's fairly new to Notch, these are some of the shortcuts that I'll be using a lot of. Included with the download package that has the Notch DFX file you were sent, there is an official Notch shortcuts PDF file, and in there, there'll be a lot more, but these are the main ones we will be using. And just to clarify, the O here is actually a 0, so that's for the switching the cameras. Okay, so let's jump across into Notch. So this is the DFX file that was provided. I've included the first few sections there just so everyone can reference back. But the very first one we want to jump into is the Procedurals basic. So this is the simplest form of a procedural. If we zoom in, we have a procedural root. All procedurals required to have a procedural root. And from there, I'm branching out into a procedural meshing node. And as we talked about in the description of the Notch procedurals, this is required from turning our generators from signed fields into renderable geometry. And down here, I'm using a primitive. I've chosen the sphere primitive because it's very simple. It fits within its box. But you may notice one thing that's kind of weird. There are these little holes you can see around the shape. Now, the reason that they happen is because our bounding box, which is the volume we've set inside our procedural, or with an external bounding box here, will limit what our procedural system will render. And this sphere is just touching the outsides. So it's going to create a hole there because it can't render what it's outside of its system. There are 3 ways we can get around this. The first way is to come in and say, I want my bounding box to be larger. So again, if we create a bounding box, search for bounding box, drag one in, and we link that up to the bounding box node here on the input, we can use our bounding box by pressing Y or selecting scale uniform and clicking and dragging inside of the viewport. So now you can see as we make our bounding box larger, the holes disappear because now the sphere is inside of the bounding box. The problem is if we make it too large, we start losing detail. So that might not be the best way to go. The other way is to come in and say, hey, let's just grab our sphere and make that smaller. So again, highlighting our primitive, pressing the Y key, and just dragging it down ever so slightly. So that's now going to make it work fine. But what if you wanted that overlap look? What if you wanted to have some harsh edges being cut off? Well, there's a great little node inside of the procedural meshing that lets us tick on seal boundaries. Now, this little checkbox here will basically put a cap on anywhere that it crosses the boundary between the bounding box and the procedural zone. Cool. So inside of here as well, we can also do things like fixing error tolerance. So if we're doing more complex shapes later on, this will allow us to fill in any gaps that pop up. And we can also add some smoothing. So if we want to crank this all the way up, we'd find our edges would start to be a little bit rounder. So if we can get something like 100, you'll find those edges are a lot rounder in that zone. Cool. So that's our basic procedural system, but obviously procedurals can do a lot more than this. Before we move on, one fantastic workflow that was actually shown by the Notch product specialist team, Ryan and Armin, is to use a Shape 3D box that has the lines renderer enabled and then the geometry disabled. And if that is set to a 2x2 box, that is exactly the same size as the basic procedural volume. So now you can get a visual representation of what your space is. And if you don't need it afterwards, you can just hide it and leave your procedural behind. So that's a really good tip. All right, from there, we want to move on and go to the first of the CSG modes. So what these are, if you're familiar with Touch Designer or 3ds Max or Cinema 4D, and you've used Booleans before, this is the same sort of system. So on the left-hand side here, we have a union. This is basically two objects that are just intersecting with each other that are now fused as one. They don't change the properties of it. They basically just, there's a hard cut line where they join. Here I've enabled colors so you can clearly see how the blends are working. Right next to that is the smooth union. Now the smooth union, when I zoom in, has the blending zone. Now this is animated just on a little sine wave at the moment, but you can see that you can actually feather this join between them, and you can just get a nice soft gradient between both the colors and the blend at the edge. So that's what the smooth union does. Subtract is the opposite. It's like removing one shape from another. So again, the same spheres are used here. The top sphere is the white sphere. The blue sphere here is now just subtracted, and that leaves that void inside it. The smooth subtract, like the smooth union, just gives us an option to blend the weights around that join. So here we can see we can just getting that nice smooth edge around where they join together. The intersection is a little bit different. It takes the parts of the volumes that are overlapping and creates a new space, a new geometry just from that overlap. And finally, one I wanted to show here was the blend, which is a really useful way of morphing one shape into another. So you can take a 3D object or a primitive and then just procedurally blend it into another shape. Now, the way this works in Notch is very, very simple. So all of these are the same setup. The only thing that's different is on our bottom primitive here, we have the CSG mode, which is currently selected as union. If I was to come in and say intersection now, our first one would change. And I could then come in and say something like our smooth union. If I disable this CSG weight I've got going before here, I can now manually come in. I'm going to go into my orbit camera on 5 and zoom in. So I can come in and manually adjust how smooth I want this join to be. So this is really, really good if you want to have something that's more like a liquid sort of look, like something bubbling out of like a flat plane, that really sort of gooey sort of look. The smooth union is fantastic for that. Now, while I'm on this topic here, I should probably show you how to set the colors up. So by default, Notch doesn't show individual colors between procedurals. That has to be enabled. So in each of these, you can come in and click the effect color. So if you go into your primitive here, we have the 3D primitive, which is the top sphere. I can click effect color, and then I can change the material color to something like a yellow. By default, there is a setting called generate colors in the procedural meshing that's turned off. So we need to enable it both on the procedural meshing node, generate colors, and on every generator we want to color for it to work. So that's how our CSG modes function inside of Notch. There are a couple of different ones, but they're the main ones we'll definitely be using. And through CSG modes, we can do things like create a simple bottle. Now, this bottle is very, very, very easy to do. There are only 4 primitives involved. There are 2 tall cylinders, a large one for the outside, a smaller one for the inside, and 2 wider cylinders. Again, a large one for the outside and a smaller one for the inside. If we look at how this particular one is made, we have our null, which is just holding it in place, our procedural root node, which is holding everything together, followed by our bounding box, which is linked into our procedural meshing. This procedural meshing now has all of these objects as its children. The first 2 here, again, we're looking at this one shape over on this side. The first 2 here are the union of these first shapes. Once that looks like this central cylinder, we're then subtracting from that the first thin shape and then the second thin shape to create the hollow look. Now, with procedurals, it is really, really, really important to remember what your stacking order is doing. So if I come into this final result over here, which is the one we've got to cut through, if I was to say change the order of operations where I would move this subtraction halfway up into the middle, now you'd see that I'm only subtracting from the bottom, but not the whole way through. So the stacking order really does matter when you're building up a procedural system. Another one to look at is the fill mode. So when you're either doing a union or a subtraction, or you want to create some sort of shape, inside of the primitive, there is an option for it to be filled or a shell. So I've got two different examples set up here, and they just have a primitive box set to subtract with a blue color removing from them. It's just a really easy way of seeing which one's which. So this would be a fast and easy way to make something like think of it as a shot put versus a basketball in sports terms. One is solid the whole way through and will be like a continuous generated volume, but the other one has a thickness, so you can puncture holes in it and have things coming out of it. So that's just one of the other things to really consider. Now, this is where it starts getting a little bit more fun. So generators, there are a whole heap of generators inside of Notch. 3 examples here are the 3D object, the reaction diffusion, and the image one. Now, they're all set up as below, but let's just, for example, let's just take one of these for a spin by ourselves. Let's just say we want to make our own reaction diffusion. So we're going to come across to here. We're going to look for our procedurals node. So 0 that out. Scroll down to procedurals. Our first point will be the procedural root. So I'm just going to turn all of these off. So our procedural root by itself does not do anything. What we need to do next is add our procedural meshing. Make that a child. And then we can look for our reaction diffusion and bring that in underneath. And what we're going to see, this is immediately going to fill up the space that's available. Now, there are a couple of inputs down the bottom of reaction diffusion. One of them is the growth restrictor, and this is going to be the shape that our shape will grow into. And the other one is the seed restrictor. So basically saying, where do we want this growth to happen? If I hit the home key, you can see this growth happens all the time. I can come in and say, I want to put a primitive emitter. Say this one here is set to a sphere that is filled. And I can make that our growth restrictor. And now it'll just fill that volume. So we can use different procedural generators that work with each other. Again, I'm just going to take that one away. Control-1 to hide. I'm just going to unhide the other versions that are here. So if we look down here, our first one off the line is the procedural generator for 3D objects. We can take in OBJs, we can take in FBXs, or we can take in just a simple shape 3D. As long as we put this into the input of the 3D object and mesh it, it will appear. One thing to be aware of if you're using animated Alembics or any sort of file that has motion, inside of your 3D object, you're going to need to tick on the animate SDF function. This is basically going to allow it to keep generating every frame as opposed to generating just on the first frame and being static. Another good thing to look at here is we have the SDF width, height, and depth. So think of this as a resolution in voxels in 3D space. I could come in and say, I want this to be 256 and really, really ramp it up. But my frame rate's going to get a bit of a hit, and it's not really noticeable here. So we can get away with using just 128. Again, we can set our master procedural meshing volume in here as well, the resolution. Next one up here was the reaction diffusion, which we just showed before. And the third one is image. So you can use any sort of image generator, or you can do a camera in or a video. And this image will basically be looking for the grayscale. So what is bright, what is dark, and basically making a depth map from there, feeding into the image, and that will then extrude out to create your procedural. Alrighty. I'm going to speed up a little bit here because we won't be covering these sections as much. So a really good thing about procedurals is they play well with other parts of the Notch system. So we can use things like level set fields to drive our procedurals. So what we have going on here is a procedural root with a procedural meshing node and a level set field generator. Now, when we hook this up to a field system here, our field level set, we can then say, I want a field emitter, which is a sphere, and some curl noise. And that will then be meshed as a procedural mesh. This is really, really cool if you want to have some sort of animated floating liquid. The next one would be the particles system. So particles by themselves can be brought in as circles or blobs. There is also a particles as primitives option to bring in. So here you actually have a bit more control over what shape these particles will be. Again, we take the particle system, particle root, primitive emitter, and some sort of motion, and we feed it into the input of the particle system. And finally, again, also using particles to drive it is the Voronoi system on the far right here. This is a little bit different. I believe it takes each particle and creates a cell measuring the distance between each other particle, and then we'll alternate which ones are turned on and off. So again, we can take the Voronoi as a child of procedural meshing, feed in our particles, and that will generate our procedural from there. Again, I apologize if I'm going through these pretty quick. There is just a lot to cover, and I will come back to these afterwards. The other section that's really good about procedurals is we can go the other way around. We can go from procedurals into other systems. So here we're going from our basic procedural, which is a procedural root and a 3D primitive. I've just got set here with a math modifier moving side to side. We don't need a procedural meshing node here because we're not actually going to render the procedural. We just need the volume data here to tell it to do something else. So out of this procedural root, we can feed into a field renderer and a procedural emitter inside the field system. So again, we're going from the procedural root into the procedural emitter of a field. We then add the renderer, we then add the curl noise, and now this simple sphere that's moving left and right is driving how to do the smoke simulation. Again, we can do this with cloners. So we've got the same exact sphere moving side to side, but we are going to feed this into a clone to procedurals node. Now, what's really cool about this is we can add a bunch of different nodes to it, and then we can have a zone absolutely filled with clones. So this is actually going to fill the entire volume with clones. And coming back to the shell versus field we were talking about earlier, if I come in and change this to shell, now I'm only rendering the clones on the outside of the shape. I can adjust that depth, but that can be really, really useful if you're generating a very, very large shape with clone to procedurals, and you don't want to be having all these wasted clones inside the geometry you'll never see. So that's another one there. The third example I have is we can take procedurals and push them back out to particles. So again, procedural root, procedural primitive, and that is going to feed into our procedural emitter for particles. And that's just a point renderer here at the moment. So procedurals are great because they do work almost as a Swiss Army knife between a lot of different systems inside of Notch. All right, this one is going to be one of my favorites. This is the onion displacement. And yes, Notch, like ogres, have layers. So we're going to start off with a simple fractal noise. So coming in, we'll go to our procedurals. We'll bring in our procedural root and our procedural meshing. But there is a fractal noise one we can choose as well. So again, fractal noise, drag that in, make it a child of the procedural meshing. And there's an option inside of fractal noise to make it the 4D time evolving, which is basically just going to step through. So I love fractal noise because you can use it to take away from things, add to things, and just add some randomness. But when combined over here with the onion displacement And these two are the same fractal noise, by the way. So if I take the onion and drop it all the way down, you can see this mesh is exactly the same on both sides. But what the onion does is it starts wrapping layers around, filling the gaps between the geometry. And you can slowly turn these layers up and up and up for a lot of complexity really quickly. Now, we were showing those examples earlier. So if you put a light inside of this and make it bounce around using the glass RT material, you can get a really, really cool effect with a very minimal amount of nodes. Again, if I take away the Shape 3D bounding box, we're only looking at maybe 5 nodes, 6 nodes to generate this entire look. The other interesting thing about the onion node is it can be colored using a color ramp. It's a really bad reason to take that away. So we can basically come in and choose colors. If you want to come across here, color ramp, drag that in, and now each layer that will sequentially change between those 3 colors. Alrighty. Now this is another technique. So before, when we were looking at those glass examples, we had one where it looked like those 2 liquids were sort of interacting with each other. The way that was done was actually just inverting the geometry here. So what we have in our first side is just a 4D fractal noise going about what it normally would do inside a system. So it's basically just the procedural root, the meshing, and the noise, and renders out looking like this. The next one across, what I've done is I've used a second procedural node. I've taken a 3D primitive, which is the size of our volume, our square, and set our fractal noise to subtract in our CSG mode. Like before, we were talking about, we can change it from always just being union to subtraction. And now I'm getting the impression. So the opposite of what is over here. When I combine both of these together, I get this really cool joining effect. Now, this is only possible because I'm using 2 different procedural meshings. So they're not going to interact with each other. This blue, for example, even if I change my CSG mode to subtract, it won't interact with the other procedural meshing node because I've made these separate instances. So basically, Procedurals treats these as 2 completely separate systems inside of the same procedural. But the really big bonus of this is, like before, we were talking about we could change colors of our procedural parts. But if we use 2 different procedural meshing nodes, we can actually change whole materials. So I can come in, change the metallicness, change the alpha transparency, and like apply one, what we might say is a really shiny chrome. And the second one we could turn into something like a fluorescent semi-transparent liquid, like a glass sort of look. So that's where we can use multiple procedural meshing nodes inside of the same system. And finally, when we're going over how to really add some detail, we are going to talk about how to add displacement. So the first example over here is the fluid displacement. So these are actually located inside of our procedural node and our displacement section. So before we've gone over onion, but now we're going to be looking at the fluid, the FBM, and the pyroclastic. So over here, we've got the procedural meshing node actually running into the fluid effector first, and then the 3D primitive sphere is the child object. And it almost gives the effect of like cloth inside of water generally floating around because we set our fluid effect to be curl noise. Over here, we can enable the FBM, which is a type of fractal noise. We can come in and basically play around with the amplitude and play around with the gain to get something really, really aggressive or something just nice and smooth. I like to use this when I'm creating false water. So I can basically create a plane, a box procedural, and add the FBM displacement to it and animate that in a distance. It's a really nice way of making cheap water. And the final version is the primitive sphere using the pyroclastic flow. So this is going to be, I think it simulates a bunch of really densely packed blobs around the surface, smooths out, and then uses that as the displacement to push away. So these are just really, really good nodes to be able to add some detail to your procedural system without having to go into normal maps or anything like that. Okay, so that's the basics of procedurals. I do apologize. We jumped through that very quickly. That is because I want to get into the basics of the glass material. And by doing that, this is the warning section. So if you are running a laptop with an older GPU, I do say please plug it into the wall. You're going to need the power. But this is not real time. These scenes that we're going forward, they can run real time, but the RT glass and especially the Pathtracer is designed mainly for offline rendering. So what does basic Pathtrace glass look like? So we can come in here, and as you can see, when I let it run, it's going to look fairly noisy. But as I stop this going, it'll start refining. And you'll see at the bottom of the screen, there's refine steps here. So what I'm doing in this particular scene is I have two shapes. One of them is being affected by a deformer. And it's just creating some nice flat light shapes to bounce around. Now, the main hero here is the glass RT node. So with ray tracing enabled inside of Notch, this is the button up here. So you will need to come up, you'll need to enable ray tracing here. You can also do it inside of the node root of your scene. So if you click on your root, scroll to the bottom and enable ray tracing. To get to this effect, you'll also need to enable deferred rendering. And for good measure, I've turned on high dynamic range and linear space lighting, just so I can get it looking fairly accurate. Now, what we can see here inside of this glass is we're getting not only the reflections off the sides like we normally would, but we're getting like the light is actually bouncing around inside, and we're getting the refraction, the distortions you'd expect from something like glass. And it's coming through here. That is actually handled by the Pathtracer node. So if I turn that off, we're not going to get anything. We're just going to get the standard sort of reflection you would normally see. There are other ways around it, but the path tracing node really does allow the best bounce lighting options inside of Notch. Think of it like how Octane Render sort of works. It is its own ray tracing system. I'm sure that the Notch team is absolutely horrified at how I'm butchering the explanation for this, but the Pathtracer basically makes everything look really nice with the lighting is set up correctly. And speaking of lighting here, I'm using a skylight and I'm using an environment image to feed it. So a normal skylight would have it looking like this. The glass still works, everything still reflects, everything still has its transparency. Sorry, I've got an itchy nose. But if we add an environment image, so again, coming over to our lighting node, environment image, drag that in, and then I am using a HDRI from HDRI Haven. It's the Shanghai Bond. Now, in your Notch file, it should be here inside of the resources. Don't worry if there are a lot of things that say a procedural emitter in here already. That's just because when we do generate a procedural volume, it will just cache it in here. So if you click on your Shanghai Bund, there's a 1K and an 8K. So if your machine is having a bit of a hard time, drag in the 1K. We want to just turn on our environment image, which will make everything black out. So we take the output of the video loader into the environment map image. And now that 360 photo we've had before is using all of the, is driving the lighting and the reflections. So one of my favorite things when using path trace lighting, and we'll get into that a little bit later, is we can actually have this really nice spill. Sorry, I pointed at the screen, behind where the light is coming through. So the light is coming through in this general direction. And at the moment you're seeing it's a bit of a shadow, but we can actually allow that colored light to spill through, which is really cool. Now, that's our basic. I am conscious of time, so I'm going to jump ahead pretty quickly here. So refraction and reflection. This is really, really where I start to really love the path tracing node. So the Pathtracer when you enable it, will allow you to set your maximum depth for diffuse, glossy, and refraction. So think of that as the amount of times the light will bounce to generate the colors of an object. So if you've got a red sphere and a white ground, the light will bounce around at least 5 times for it to register, and you can get more of your light bouncing. Light goes into a far higher quality for a render. The glossy depth is if you've got a bunch of mirrored scenes, how many times will that light bounce around? How far can you see into that mirror maze? That's the glossy depth. And the refraction depth is how many times it will pass through the surface and still refract inside. And what you'll find is if you have things like this shape 3D plane, this rounded cube here, if I was to create a second one of these and move it backwards in space, and I came to my refraction in my Pathtracer and dropped this down, you'd see this black. Now, what's happening here is the light is passing through one surface, out the other surface, and then it's saying, I've done my bounces. I'm going to stop. I'm not going to return anything further from there. And that's why we need to crank this up to something like a 5. So now the light is bouncing around more than the amount of times it has to cut through a surface. I love how simple it is to create this system. So all it is one plane with a texture in it, one simple box. The box has the glass material turned on. It's just got some modifiers, continuous modifiers that are spinning it around in heading and pitch. And inside of this box, I've just put a sphere. And that's just to show how the glass handles the refraction and the reflection around it. So you can get a really high-end, nice-looking render. Again, here, I've got the refine steps set to 50. And that took me 5 seconds to render out. So another thing I would like to touch on at this point, and again, I apologize for talking a lot without us doing a lot of things, but there's a lot to cover here. The RT refinement section here is another node. So again, if you type in refine, you can get the RT refinement. And this will say, all right, I want the ray tracing passes to stop at a certain amount. Let's turn this off. Like normally by default, I think it's 1,000. So you'll see down the bottom of your screen, this little refine steps number will just keep counting up to 1,000. Now, if you're working on something that's like a render to get out to production, you can play around with finding what is the optimal number of passes and limiting it here. I say 50 is working for my shape here. 50 passes is good. The other thing that is fantastic, and again, I work with an Intel CPU and an NVIDIA GPU, is an AI denoiser function built in. So I can get away with running something like 5 passes, and then it will still resolve. So if I take that off, at 5 passes here, when I zoom in, you're still going to see a lot of noise. But if I enable the AI denoising, all of that's now smoothed out. It does take a little bit of extra time, but I can get away with rendering this much faster, especially on larger scenes, by rendering a fewer amount of passes and just turning on the AI denoiser. So in this particular scene here, we basically took a shape 3D rounded box. We could make it let's go an icosphere, a little bit larger. There we go. Let's make the sphere inside it a little bit smaller. And now that's moving around and refracting around. Probably not the best example because it doesn't look quite as nice as the box. So jumping back out. Oh, another thing to remember is if you are working with large scenes in ray tracing, just turning off this little checkbox, the little ray tracing button, will allow you to move around your scene much faster. Then you can just re-enable it back when you need to look at things. So this is one of my favorite things about Pathtrace glass. It's translucent shadows. So we're talking before, the light comes through and we're getting that nice, beautiful spill of color onto the ground here or onto the surface. One second. I'm just going to disable the ray tracing so I can actually move around my scene. Here we go. So what I've done in this particular scene, if we zoom out, is I've set up 6 different lights. So there is a skylight as normal with the environment map, a skylight with the environment map that has the shadows, translucent shadows turned on. And we can switch between these using the select child node up here. So if I go to the 0, so by default, the skylight won't have translucent shadows on. With translucent shadows, we now get this beautiful blue sort of spilling through. It also just helps make the glass a little bit lighter as well. It looks so much nicer. All right, if I step to the next one, which I've got 2 for here, is an area light. So an area light at the back, just this large white light. Again, it's just throwing a normal dark shadow. It's not treating this as glass. It's just treating this as an object that it can't shine light through. But on this area light, the second option here, we also have translucency turned on. So when I move across to this light, we now get this blue starting to filter through. So again, going between no translucency and the translucency. And the final example, you probably wouldn't use this, but it's good for just accentuating color coming through. We're using just a normal light. Even these lights can have the translucency option. So coming in here, let's go to option 4. The standard light just treats this as a solid object that it can't get light through. It's just shadows. Coming in here, we have these really solid colors coming through. So that is enabled by coming into our geometry down here. Inside of our glass, we not only have the option for our specular colors and our refraction amounts, but we have an absorption slider here. This is what is actually doing all the work for us. So we can color things with a diffuse coat by saying, I always want to make this like a purple. All right. That's a cool way of just getting a quick color. But if we make that color by using the absorption, so I can say, come in and make it a pink, and turning our absorption up, if we've enabled translucent shadows, we can now get that color to spill out onto the environment. I'm going quickly here because we've got one more to cover and we have 3 minutes to do it in. So we have the materials and HDR skylight. So this is using a procedural system similar to what we'll be building in the next session. So 2 different procedural sets. And this is the skylight with the video loader. So what we've gotten here is the same Shanghai Bund background running into the environment image we used before and a skylight. But what we've done here, just to make it a bit more visible to the world, is there is a visible skylight, a visible sky dome option you can tick on. And that just helps ground this object in wherever it is in space. So if I was to come into our 5, if I look around, I can place the object inside of a skybox. So with that is the quickest, dirtiest, fastest way I could cover both of those systems that are required for the 2 sessions we're using next. So just capping off quickly while I've got a couple of seconds from the top, we went through and we covered how to seal up our boundaries. We covered the different types of CSG nodes. We covered how we can use a relatively small amount of nodes to create complex shapes with holes. We talked about how we can use different systems inside of Notch, like saying our fields drive our procedurals and the other way around. And then we started talking about how we can displace otherwise very simple procedurals into much more complex shapes. So at that, I'm going to say, let's take our first 10-minute break. And we'll come back next and we will be building the first of our looks, which will be this glass tower you see on the left here. Okay, Yuki, do you have anything else to add, or are we good to go to the first break?
Yeah, thank you for the first part. Okay, so the please come back 10 minutes later. I mean the UTC -7. Your time 6 p.m. right?
Yes.
Okay, and people from Japan, please come back 10 a.m. Yeah, so early morning today. Thank you so much.
No worries. I will be back in 10 minutes and we'll go through our first of the workshops. Thank you very much. And I do apologize again if I went through that very quickly. I'm happy to revisit any of those in the Q&A at the end.
Thank you. Okay, see you in 10 minutes.